Okay, good afternoon, class. So today we're looking at financial maths. We're looking at the examples for exercise. (11.5). Exercise 11.5 is on page 378. 38. Page 380. The examples on page 378. Right, timeline. The timeline is useful in financial mathematics when there are several deposits and withdrawals, as well as possible changes in interest rates. So in our previous lesson, we looked at timelines. Not so. And you guys were exposed to timelines in grade 10 as well. Okay. The timeline provides a visual summary of the information. Okay. That's fairly straightforward. Let's look at example 1. Example 1 is on page 378. We are told. Just close this door. Okay, so we are told that the savings account is open with a deposit of 9,400 rand. So of course, if it's so bulky, a lot of information, we know we're going to draw a timeline. Okay. So let's go. It's open with a deposit of 9,400 rand. 2 years later, so that takes you to T2. A further 5,800 rand is deposited, is added to the savings. So a deposit we indicate with a plus, whilst a withdrawal we indicate with a minus. 5 years after the savings account was opened, another 12,600. So that takes you to T5. 12,600 then is deposited into this account. The interest paid on the savings is 9% per annum compounded monthly. So it's a straight 9% or a flat rate of 9% per annum compounded monthly. Calculate the total amount saved at the end of 8 years. So that takes you to T. Okay. Now people, there's more than one way to do this. Okay. As we showed you yesterday, you could have broken it up the way Rattenpede prefers. Break each one up and then you take it from there. Or you put everything one time into the calculator. So I'm going to go with a straightforward calculation. Otherwise, in the description box, in those videos 2 years ago, I've explained it, the broken up method. Okay, where you break it up and you're going to carry on that answer throughout. Okay. So let's go. I'm going to go with straight into A total. Is equal to P into 1 plus I to the exponent. Let's go with the first one. What is happening to the 9,400 then? Is the interest rate changing? No, it remains constant. Okay? What? You're disrupting me then. Alright, so that's a straightforward calculation. For 9,400 and there's no interest rate change. So what I do is I take that 9,400 to the end. So it's going to be 9,400 into 1 plus 0,09 over 12 to the exponent 12 times. And how many years is this for? 8 years. You see that, people? Plus. So now that is accounted for now. So what we do is we now take 5,800 rand to the end. So it's 5,800 rand. What's happening? It's throwing an interest of 0,12 over 0,09 over 12 to the exponent 12 times 6 years plus 12,600 rand to the end. So it'll be 12,600 rand into 1 plus 0,09 over 12 to the exponent 12 times. And how many years is this for? 3 years. You guys understand? So what I do is I put that into the calculator. I close it by mistake. $9,400 into 1 plus 0,09 over 12 to the exponent 12 times 8 plus 5,800 into 1 plus 0,09 over 12 to the exponent 12 times 6 plus 12,600 into 1 plus 0,09 over 12 to the exponent 12 times 3. What could have this written 36 and 72 and 96. You know answer of 45,000. Sorry? 681 comma 16 cents. 60 cents.
Sorry?
Yes, ma'am?
Isn't the Sununga issue with you?
Is she with us? She's with BH.
Okay, thank you, Melissa.
Okay. Alright. People, any confusion here? Otherwise, as I said, the other method, how would we have addressed that one? We would have said 9,400 rand into 1 plus 0,09 over 12 to the exponent 12 times 2. Then I would have worked that calculation out. No? Then what I would have done was, I would have added 5,800 rand. Then that now becomes your p-value at that point. Can you see that? And then we say that answer into 1 plus 0,09 over 12 to the exponent 12 times 3 years. Then what do we do then? With that answer, I add 12,600 then, which now becomes your p-value. You see that, people? Use that answer into 1 plus 0,09 over 12 to the exponent 12 times 3 years. And that's how we will calculate it. It's a lot of more calculations as than what we have completed here. You guys understand? See, any confusion? Again, as I indicated, that since last year I've been doing this method, because I have just found the learners finding this more easily to work with. But if you want to go have a look at that, you'll find it in the description box below. Okay. We will example 2. Example 2 is on page 379. Right. So here we are told that Mr. Pillay opens a savings account and deposits 31,000 rand. Yo, a lot of money, ne? So it will be T0. But to you guys, this will always be peanuts, ne? So 31,000 rand. 18 months later, he withdraws 7,200. Remember, our timeline is a representation of years, time in years. 18 months is how many years? 1.5 years, not so. 18 months later, he withdraws 7,200. So it's minus 7,200. Okay? 3 years after he opened the account. 3 years after he opened the account. So that takes you to T3. 3 years after he opened the account, he deposits a further 30,500. So that would be plus 13,500. 1 year later, so that takes you to T4. 1 year later, he withdraws 6,700. Calculate the total amount of money in the savings account at the end of 6 years. If the interest paid on the savings is 10% per annum compounded quarterly, so it's a flat interest rate of 10% per annum, so 0,01. 0,1, sorry. Compounded quarterly, so it's 1 over. Okay. So any confusion with the way I set this timeline? You all understand? Right. Let's go. So people, what's the time from T0 to 1.5? That's 1.5 years. Not so. From here to there, 1.5 years. And that from there to there is 1 year and there is 2. Okay. Now, you wasn't a maths class, my son. Come last to them, they can come at the end. I'm almost finished. You're wasting my time, Michael. Okay. You need to know that once you're going to break up the time, okay, and you're going to do each section on its own. Okay, where am I using the total on its own? So we're going to go A total is equal to P into 1 plus I to the exponent. So A total. So we're going to consider that 31,000. Does the interest rate change? No. So it takes you all the way to the end. So it's going to be 31,000 Rand into 1 plus 0.1 over 4 to the exponent 4 times. And how many years is that going to be for? 6 years. Okay. Plus. No, not plus but minus. Why minus? Withdraw. You're withdrawing 7,200 Rand. So I'm going to take that to the end. Okay, into 1 plus 0,1 to the over 4 to the exponent 4 times. And how many years is it from there to here? 4.5 years. Why? Because that was 1.5. 1.5 plus 4.5 is 6 years. No? That is 4.5. Then what do we do? Then we plus what? 30,500 Rand into 1 plus 0,1 over 4 to the exponent. How many years is that going to be for? 3. So it's 4 times 3 years. You guys understand? And then what do we say? Minus. So we're minusing 6,700. Minus 6,700 Rand into 1 plus 0,1 over 4 to the exponent 4 times. You guys understand? Here we're taking each amount individually. And the Ratnavili is going to rather do the other way. So what she's going to say is 31,000 Rand into 1 plus 0,1 over 4 to the exponent 4 times 1.5. Not so, she gets the answer. She gets an answer. And then she subtracts 7,200 from that answer. That becomes now your principal. Not so. Then we go with that answer you're getting into 1 plus 0,1 over 4 to the exponent 4 times 1.5 again. With that answer, she's going to add 13,500 Rand. Once she's done that, that becomes a p-value at that point. Okay? And now that p-value, there's a different p-value to that. Okay? So we now say that answer we get here into 1 plus 0,01 over 4 to the exponent 4 times. And this is for 1 year. From T3 to T4 is 1 year. Okay? That answer we get from there. What do? We subtract 6,700 and from that answer. With that, P3 becomes a P value for this part of it. You see, so there's a lot of rewriting of numbers and things like that unnecessarily. But if you feel that that is going to work for you, by all means. Okay? And now how to mark it if you're going to go down that route. Okay? So my A total is going to give us. So let's go. So it's 31,000 into 1 plus 0.1 over 4 to the exponent 4 times 6, which is 20. You want to agree with that? Minus 7,200 into 1 plus 0.1 over 4 to the exponent 4 times 4.5 plus 30,500 into 1 plus 0.1 over 4. Sometimes the memory of the calculator is too little for you to punch everything. Okay? I think this is one of those sums. To the exponent 3 times 4, which is 12. That is why I'm putting that multiplication one time. Okay? Minus 6,700 into 1 plus 0.1 over 4 to the exponent. You see it's going, which means you say it's coming to an end. Then you give you an answer of 54,000. Just check if that's right. So it's 54,833 rand and 66 cents. Now it could have been if I typed this whole story out here. If I had said 3 times 4 there, 4 times 3. It might have well been that it wouldn't have given me that opportunity to take that exponent there. I'll just show you then what you do. So we said plus, minus 6,700 into 1 plus. Okay, still giving me the option. You see, it's not going to give me a chance to get that exponent. You see that? So how do I counter that? I counter that by working that out. 24, that I left like that. That gave me 12, and this gives me 8. So I counted it like that. Or, another way I could have done was, what you notice here is that the interest rate gets repeated all the time. Not so. And what is the interest factor here? What the interest rate? The interest factor is 1 plus 0.1 over 4. Can you see that? There's it again repeated. There's it again repeated. There's again repeated. You see that, people? So a shortcut would be, I put in the calculator my 1 plus, I say 1 plus 0.1 over 4. Which everything in yellow is actually 41 over 40. You see that? But if I press my answer button, what do you notice? 41 over 40. Can you see that, people? So what I do now is, I punch the story in. And this can only be applied if we are applying this method. Because the other method is now broken up into all these smaller fragments of calculations. Not so. But because this is all in one, I just go now 31,000. Instead of pressing 1 plus 0.1 over 4, what do I press? Answer. To the exponent, 24. Minus 77,200. Answer. To the exponent, 4 times 4.5. Plus 13,500. Answer? The exponent? 12. Minus 6,700 and answer? The exponent? 8. Give me again an answer of 54,000. 54,833 rand and 66 cents. Same answer. You guys understand? Okay. Again, if you're going to break the sum up and you're going to go with that other longer method, because the number you are rounding off all the time, if you're not going to use the answer button in that other method, where you're going to take 31,000 for 1.5 years and then you're taking that, and you're not using the answer button, you will see that your cents will be a bit out. But in the exam, we will accept that as full marks. Okay, you guys understand? So if you got maybe 54,833 rand and 70 cents, or 62 cents, or 70 cents, or 75 cents, then we would have given you the mark anyway. You guys understand? So we give you leeway when it comes to your financial maths and the method you're using. Okay. Alright, any confusion there, people? Alright, so that basically brings us to the end of the examples for exercise 11.5 on page 380. We're going to do the odd numbers for homework. Alright. The full lesson can be found in the description box below.